Welcome to the tutorial series of ANSYS 2018. In this series, we will gonna analyze different kind of structures like beams, slabs, retaining walls, and much more in ANSYS APDL as well as in ANSYS Workbench. But before starting my video, I would like to request you to subscribe my channel and press the bell icon for the further notifications. First of all, let we discuss about our series. I would be uploading the tutorials of different beams and retaining wall, slabs, and same such other type of structures as well, including some of the plates, mechanical components as well, in ANSYS APDL and ANSYS Workbench as well. Basically, ANSYS APDL gives us a more control over the cross section. It gives us a more parametric design. But I would be uploading the tutorials for the both, so you can decide whatever is easy for you. In this tutorial, I would be doing the analysis of a simply supported beam, which I will just assume so that you just know what are the different steps for the analysis of any type of structure in ANSYS, and especially in APDL. For any type of structure, these steps do not vary very much. So I would just start. First of all, I have just opened my ANSYS APDL. I am using 2018 version. You can choose any version. It does not. It only just contains some of the additional components, but more or less the basic tools are the same in all the versions. So first of all, you must have the ANSYS APDL installed on your PC. Then after opening the ANSYS APDL, first of all you would select your directory and your job name, title, such these things you would decide. After that, first of all, the thing you would do is go to preferences and you would select the analysis type. So I would be doing the structural analysis. I would simply select this type of, and I will simply press OK. After selecting the analysis type, I would go to simply preprocessor, and first of all I would select the element which I would be using for my analysis. Since I am doing the analysis of a simply supported beam, so I would simply go to element types and add my element. I would be doing the analysis of a beam, so in the structural mass I will go to the element beam. In the element beam I have two different elements under 3D finite state, which is 2 node 188 and 3 node 189. I would be using 2 node 188. Now what's the reason for using 2 node 188 and why I did not use the 3 node 189? Basically 2 node 188 is element used for the straight beams, which I am going to analyze in this tutorial, and the 3 node 189 basically is used whenever we have a curved beam, like in case of arches. We have a start point, we have an end point, and we have a point on the crown level as well. So in that case, if I am going to analyze curved beam, so I would be using the element 3 node 189. But since I am using a straight beam, assuming a straight beam, so I would simply use 2 node 188. I would simply click on OK after selecting the beam element, beam 188. So I will close the menu. After adding the element, I would simply go to my material properties and define my material model. For the current case, I am just going with the linear and isotropic model. So in this, for a linear isotropic material, I would have to enter its modulus of elasticity and its Poisson ratio. So I am assuming a modulus of elasticity of 210 gigapascal. So I am just putting its value, and for a Poisson ratio I would be assuming its value to be 0.3. Usually its value is between 0.2, 0.15 to 0.3. I am assuming its value equal to 0.3. I simply click on OK, and now my material model is defined, which is linear isotropic. I can define more material models for the same model, but I would be going with the one just to give you the idea of the steps for the analysis. After defining the material model, I would simply go to sections. In the sections, since I am using a beam, so beam, you all know that beam is a line element, you must know it very well. So I am considering that my beam is rectangular, so I would go with the same section, and I am considering that my beam width is 0.5 meter and its depth is 0.75 meter. Applying it to be okay. Now considering my beam section, after I have selection of my sections, Now I will go to modeling. In the modeling I will go to create, and since I know that my beam is a line element, so I can simply create direct lines, but I am assuming that my beam contains 3 spans on it. I can change it accordingly, but in this tutorial I will be going with the first of all I will be going to the key points in the active coordinate system. First of all I will defining my first coordinate as from the 0 0, and then my second coordinate at a distance of half meter from the first coordinate, and my third coordinate to be at a distance of 1 meter from the first coordinate, and my fourth coordinate at a distance of 1.5 meter from the first coordinate, and my fifth coordinate at a distance of 2 meter from the first coordinate. Now I have basically 5 different key points. Now for putting these key points is that I contain a simply supported, I am doing the analysis of a simply supported beam. I have the hinge support at key point 1 and a roller support at key point 5, and I am assuming that it is loaded with point loads at 2, 3 and 4. At these 3 key points I will be applying some point load. We will be applying with the UDL as well in the upcoming lectures, but for the current video I would be going with the uh, point load. Now after creating the key points, now I have discussed earlier that our beam is a line element. I simply go to lines, and I would be drawing a straight line since I am going a straight beam 188, and after that I will simply draw my beam. So here you can see that my beam has been drawn. So I have 1 2 3 4, 1 2 3 4. So I have 1 2 3 4 4 different spans. After selecting my beam lines and 4 spans, now I would go to the now my model has been prepared. After the modeling we usually do the meshing, so I will simply go to meshing, and first of all in the meshing I would control the check out the size of my meshing. So I will go to manual size, and I am considered lines, so I am go to lines, and for all lines what I will do, I wanted that my each beam element, so from one key point 1 to key point 2 I have a one element. So what I wanted that one element is further subdivided into 10 elements. So I simply press OK. Now my each beam element is divided into further 10 elements, so total I have 1 2 3 4, so total I have 40 elements. Okay, after that what I will be doing, I would simply go to mesh and apply the mesh on the lines. I will select the lines and mesh each line. You can select the type of meshes for the areas. Since I beam is a line element, so we'll simply go to lines and we will simply mesh it. We would be checking the mesh tool as well in the upcoming videos. So for the time being I am going with this simple method. Now after the meshing I will be applying my boundary conditions. So I will go here and first I will click on multiplots. So now I would go here and plot the key points. So I assume that I have a hinge spot at my first key point and a roller spot at my last key point. So I will go to apply and structural displacement on the key points. Selecting my first key point I will go to apply, and applying since I am considering a hinge spot, so we know that a hinge spot restricts movements in vertical and horizontal direction, so we do not have any rotation or in this, so in the horizontal and vertical direction. In this case for hinge spot we will also assume that u force in the third direction is also 0, since we are doing 2D analysis, so always we will consider the force u z displacement in that direction equal to 0 for our 2D analysis. But in case of hinge spot we will have the rotation in the third direction. So I will simply apply it. Now my hinge spot is applied. Now I will consider my this spot and I click on apply. Now in case of roller sport we know that we have a restriction in only one direction, so what in the direction which we wanted to apply, and we will also apply it the restriction on uz as well, because I am considering a 3D analysis 2D analysis, and so it is restricted in the third direction. Okay, displacement value is 0, so I write it 0, but it's defaulted to 0. I simply press OK. Now what I will be do, since I have defined my meshing and boundary conditions, now I will apply the loads, forces, and on key points I will be applying a for key point on this. So what I will be applying, I assume a point load of, for example, 300 newton in the vertical direction. The negative sign indicate that it is applying in the downward direction. Since our vertical y direction is upward, so negative sign will assume that our load is applied in downward direction. So my load is applied. Now I will go to and multiply. So my all thing is applied. Now I will simply go to solution, and after going to the solution, I will simply solve by using this current load step file. And this we have the different settings of our analysis. We will not changing these settings, but in the upcoming lectures, in the upcoming tutorial, we will be seeing the different settings, that what happens when we change different settings. So my solution is done, as you can see that. Now whenever my solution is done, I will simply go to general prospectus, and in the general prospectus I would go to plot. For the deform shape, I will go to plot results, and I will go to deform shape. So I wanted a deform shape of my beam. I just applied it. Now you are seeing that it is appearing like a line element in front of me, but I wanted that it appear like as it is my own beam element, which I have designed, which I have made of 0.5 by 0.75 meter. So I will go to plot controls, and here I have the option of style. In the style option, I will simply go to size and shape. Here the size of shape, I will simply turn on the element, and now you can see that my beam element is visible in front of you. Okay, so this is our beam element. You can see it in this direction as well. So after that, what I will be doing, if you wanted the contour plot, wanted to find the stresses, we will be discussing the what kind of stresses we usually want. But one message stress we usually want in every case. So simply find that, so you can see that this is a common picture which you usually see in your finite element analysis books. So this is the finite element analysis of a simply supported beam, and this is a general procedure of a assumed beam. We can also see the displacement, the stresses for each element by using the defining the element table. But for the time being, I am just restricting myself to only the simple analysis and the one basis stresses and the deformed and undeformed shape. In the upcoming analysis, we will be discussing beams in the ANSYS Workbench. The same beam will be analyzed. I will try to analyze in the ANSYS Workbench as well, and then we can compare the results of both the softwares and the workability of both versions. So if you have any question, you can comment me below, and if you like this video, then do subscribe my channel and press the bell icon for further tutorials.